Hello everyone. Today we shall be looking at how to design a hydraulic circuit for a car crushing machine. So the problem here is design a hydraulic car crushing machine with accumulator. We could design one with an accumulator, but this time we are designing it with accumulator simply because we want to save energy. We want to reduce the size of the tank and then the size of the motor as well. So we will be designing it with accumulator. Now these are the components that you will need for the design for the pneumatic circuit. So you will need a double acting cylinder. You will need three five ray DCV spring centered. You will need your pump, pressure relief valve, and the tank. Again, there are some other measuring instruments that you will need: pressure gauge, and then we've got here a pressure indicator, accumulator here, and this is 2-2 valve to be used in the circuit for safety reasons. So let's do the connections for the pneumatic circuit. Here you can see that I've got a non-return valve here also for the proper operation of the circuit. Now I'll explain that later. So I'll do the connection here. And then I will connect that to that. Then this to that. That. So this is the pneumatic circuit and it's all done. The reason why I brought in this non-return valve is to make sure that the fluid, the oil that goes through this direction will not return when this accumulator is in operation. Because when it's in operation, it might like to return through this path back to the tank through the motor. So if this is there, this is not going to happen. Then I've got this here, pressure relief valve, just to make sure that if the pressure exceeds the working pressure here by at least 20%, this pressure relief valve should open. Now we can check the operation of the pneumatic circuit and see if it is working. Yeah. So I'll press this bit here and it goes, that bit here and it returns. Now let's configure this valve here. The solenoid there will be designated as Y1, and then the solenoid here will be designated as Y2. Now let's configure this cylinder, and the positions will be B1. I'll be using reed switch. So B1, and it should activate the switch when it's just at 0 to 1 millimeter. And then B2 when the valve has the cylinder has outstroked. I want it to activate it when it's almost at 200 millimeters. So 99 to 200 is fine. Because the maximum travel for, or the maximum stroke for this cylinder is up to 200 millimeters. That's the software that I'm using. Otherwise, others may have even up to 5,000 or more. This has been configured. Now, this, I guess, has been configured already as Y3, so that's fine. Now, let's start with the hydraulic circuit, sorry, the electrical circuit, and this is going to be a ladder circuit. So I will go to the ladder symbols here, and then what I would need is to get the power supply. So I'll pick 24 volts, and then I'll pick it neutral, which is 0. Then I'll put them apart this way. This is the way you construct your ladder circuit. So I'll connect the two together and then pull them apart so that the horizontal ranks will be the other components. Now let's go straight away to the relays, and I would need 2 solenoids and 2 relay coils, one up here and then one down here. So what I'm going to do is to connect them horizontally to the ladders or the power rails. This will also be connected. Now the next thing that I have to do is to get my switches. So I go straight to switches, and I will first of all need I will need a manual switch. So I'll pick one here and put it in there. And then the next will be general switches. So I'll pick one here, put it here. And then I'll pick another one and put it also here. The reason why I've put these switches here is that I want to latch this relay when it's in operation, simply because this cylinder here is not a memory type. It's not a memory cylinder. Sorry, this DCV here is not a memory DCV, simply because I've got this spring, say it's spring center. So the moment you shift and you let go, it will just return to the center position. So we have to latch it so that it will stay until the piston moves out completely or moves in completely before it shifts to the center position. So I'll get this also connected here. Now I'm going to label the relays and the solenoids. So this one here is given as CR1. As you can see there, this will be CR. That's coil relay 2, and this will be Y. The solenoid here will be Y. 1, which corresponds to that, and then the one here will be Y2. This one corresponds to that one here. So we've got this in place. What we are going to do here is that because we want to get this part of the circuit here latched, this relay, the switch for this relay will be given to this. So that's going to be CR1, and then the switch inside this relay will be given to that one. One of the switches inside that relay will be given to that. Now we need switches to activate this and that solenoid here. So what we are going to do is that for Y1, it's relay 1 which is going to activate it. So that's going to be CR1. I'll say okay. And for Y2, it's going to be this relay coil here that's going to activate it, and that's going to be Y2. So the moment this relay is in operation, this switch has to close. The moment this relay is in operation, that switch has to close. And remember, relays can have 1 up to 4 switches. So one of the switches for this relay is being used on that, same as that one being used on this one. So this is done now. What else do we need? We need some few safety devices in here. Let me just give this one as PI, that is pressure indicator. Let me go back there again to change this color to red, so that when the pressure indicator is on, then it will come red depending on the pressure we set on this. And this is pressure gauge, so I'll leave that one. What else do I need to do? What I have to do is now to bring in the conditions. The conditions are such that this one must be pressed, and that the piston must also activate the limit switch, the first limit switch, that is B1. So before this cylinder will move, the cam on the piston must sit first on the limit switch B1, and then there should be human intervention, somebody pressing the switch here. That's the push button here, PB. So to meet that condition, I'll bring this switch here to represent B1. So that is B1. So that we can meet the two conditions. The cam sitting on that, and then somebody pressing that, so that this CR1 can now receive input. The next will be this relay. It has to receive input as well. It's only receive input when the piston has reached B2. Okay, so we will put this here and then keep that one as B2. And what else is left? Few things more to do. So what I'm going to do at the moment is just go straight down to measuring instruments, and then I will pick an indicator light here, put it here, connect it here, connect it in parallel to that, and then another one here, connect it there, and in parallel to that. So what we are trying to do is that the moment this solenoid is in operation, this light must come on. And the moment this is in operation, this light must come on. I will change the color to green, indicating it's on. And then I'll change the color of that one to green, indicating that it's on. Now, one safety thing I want to bring in here is I need one more of the solenoids to put it here to correspond to this white fray here. What we are trying to do is to operate this electrically. So I'll go to switches again, and I'll pick a switch, manual switch here. I'll pick this mushroom one and put it on here. Again, I will need this one of these lights here. Now, the reason why I have brought this solenoid here is to be able to use this electrically to operate this one. And the reason why this is here, this valve is here, is that in case there is any fault in the system and we want to operate the system, this will be charged. This is already charged. This accumulator is already charged. That will be already charged, and it means once it's charged, there is power in it, there is energy reserved in it, and it can actually do work. So before you work on this system with accumulator, you have to make sure that you discharge this pressure here, or you make sure that you de-energize the whole system. And to do that, we brought in here this, so that this can be energized, de-energized, to allow the fluid back into the tank to de-energize the whole system before it will be safe for you to work on. It can be done manually, it can be done electrically here. So you can see the manual detent switch here, which can also be used to do it, or you can do it electrically, and when it's on, this light should come on. I've made it green, it should come on to tell everybody that this switch is in operation. We can make this one PB two. Now, I guess everything is fine. We should be able to operate it to see if everything is working the way it should. But there are a few things here, and I will show you. Let's see, there are a few things that's supposed to come in here, this rank and that one here. Yes, so here you could see that now the piston has moved out to its maximum position. It's now activated B2, and relay 2 is activated, but this is not deactivated. CR2 is not deactivated, but CR1 is also in action, and which means that CR2 should be deactivated, but it's not deactivated. So what should we do? What we can do is to put a normally closed switch here, which is a CR2 switch, normally closed CR2 switch here, so that the moment this is energized, that one opens. So let's do that and see what happens. So this is normally closed, and I will name this as CR2. Now let's simulate it once more and see what happens. So it's now working perfectly. It's working perfectly. But you can also see that this is not the energized. This is not the energized Y2. So what we can do is that to put a normally closed switch here and name that one as B1. Yeah, so the moment B1 is now made, that line here is deactivated, and which means that this Y2 here will be deactivated. Now, this is what I was telling you. Can you see that because now the system is now not in operation, this is charged to 4.5 MPa, depending on whatever pressure you will set, because this has to be set higher above the pressure, the working pressure in the system here, the working pressure in the system here. So depending on whatever pressure you set here, this has to be set above that. But now, as it is full, this now opens, the relay valve now opens. That has to be set about 20% above the system working pressure here. Once that is open, in case there is a fault in the system, this is what we have to do. We have to de-energize this one. We can't do it manually, so that the system is now depressurized. It can be safe for us to work on. Or we can also do this by pressing this switch here. But when we press this and we work on the system and we finish, when we release it, we have to release this because there is a detent switch here. Thank you very much for watching, and expect some more videos.